The essence of chemistry is knowing the truth of all matter that surrounds us and being able to manipulate it. And to me, that is magic.
Because only if we can address a lot of the issues we have right now, we can still be thriving on this planet for hundreds of years to come.
What you know from history is that whenever you need to solve such big, grand challenges which we're facing nowadays, you need breakthrough innovation.
The idea of working in a vacuum without any sort of robustness is antithetical to science. If I can't have an idea that my colleagues could review and develop on, then there's no point to the science.
Really, my driving force is trying to understand why things are happening. Really on the fundamental level of the electrons and the nuclei of a molecule.
Chemistry has a lot of potential to deliver any product that we want in society.
We do science because we are curious and we want to understand how things work.
And if you want to solve a complex problem, you need actually the expertise of everybody. And I think the foundation in chemistry is the physical formulas and the atoms from which you build molecules. But the point is to find the patterns. What is going on in these molecules and how they translate into chemistry. And so what you see here, that comes from 30 years ago. But now we are entering a new era of computational experimentation. So now we have models that are both correct and accurate. And that is the next step. That's the chemistry 2.0.
My colleagues who are in the lab or within other disciplines, they think of chemistry in the sense of structures that they draw on the board, that they write on paper. With the help of these models, of these quantum chemical models, we can understand how chemistry is happening. We can get more insight into the chemical structure with respect to how they used to do it. We can really look at the molecules and see how they interact.
Compare it to an architect. We can actually really create new, different chemical entities to design small molecules. And I try to understand the mechanism of action.
Why we need drugs is basically that they work on proteins in our body. We can, with our models, not only look at the structures, we can also look at the dynamics. And what we can see here is the kind of motion that is possible also in this protein. And once we understand this, we can try to adapt and design the drug molecule to make it fit better.
We're trying to make very complex molecules in the laboratory in an easy and efficient way. These tools are the catalysts. We need the right catalyst to catalyze the right reaction. Unfortunately, these catalysts are very hard to optimize. So we're using the computer to first simulate the reactions and then later on try these simulations out in the laboratory.
Catalysis deals with enzymes, so we can give enzymes better properties, so kind of giving them new hands to do extra work which they couldn't do. There's still so much to learn.
If we take a traditional rational approach, you can really make things that make sense. If you start with randomness, you have the possibility for surprises. What we try to do is find new ways that we can start that drug development process. And we need to separate from that huge collection of junk the few little pieces of gold that are in there that gives us the best possible starting point for drug development.
I investigate the linkages between molecules by forging linkages between researchers. Beyond their own little niche, we try to build a platform to look at toxic events in humans. And so I really believe that the synergy and the mutual support of multiple techniques is really essential for this sort of good science.
How do they look? They look fine, but they need a bit more time to grow.
Oh yeah, they look really nice.
These are human cells that we grow in vitro. We can use them to screen toxins. I think it's very fascinating to work with cells because cells are the smallest unit of all life. I think it's really exciting to find out at the cellular level what a compound does.
So basically what we're doing here is we're understanding more about biology on a molecular basis. And this is all done with chemicals and small molecules.
When we want to measure if something is metabolized or not, then we need the help of the analytical people.
For me, it's very important to study things in a cellular context so that we have a better representation.
So still not understood what's the role of some proteins in cancer. We also want to try to focus into only pathways that are activated in cancer.
I find it fascinating how your own cell can mutate and become an aggressive cancer and thereby harm your own body.
So if we really want to make a step forward into understanding diseases like diabetes, obesity, cancer, fatty liver disease, we really need to look into the dynamics.
So what we do with this setup is we actually analyze diseases. We need to understand what is going wrong, why it's going wrong, and what are these first steps. And would it be great if we can already address those steps, so before it really goes wrong, and then developing the techniques to do it.
The most bioactive mixture in the world are the venoms.
You can basically see venom as sort of a cocktail of over 100 different compounds, and we call them toxins.
So if we can identify the toxins in there and then study them as a candidate for new drugs for humankind.
And you need to be able to talk to people and ask the right questions to understand what they're doing. That is what I try to do.
Their work would not be worthwhile while it would not be brought further. And to do something that is never done before, to develop knowledge that has never been developed.
What ways and what is necessary to bring that to the world and make a real difference. And I really like to work with students. They inspire me. There's always something new. There's always something different.
Once they see this light, then I'm very happy. And we can introduce innovations, and in this classroom we see the result of that. You see them in 2-3 years develop to adults that are motivated. It's great that they want to improve themselves.
I like what all my colleagues do. I feel a very strong connection actually with all the sub-disciplines.
I think the people make it fun.
It's a very nice atmosphere to work, which really brings all these different types of chemistry together.
Together we achieve fantastic things.